Okay, we're going to start our current electricity unit. I think you're going to like the unit a lot. It's fairly straightforward, pretty easy, and it's very applicable to real life. Everything we use that uses electricity is using current electricity. So our lights, our computers, our clothes dryers, hair dryers, all of that is using current electricity. Current electricity is the continuous flow of charge. Okay, so the charge is continuously flowing through, say, a wire, as opposed to static electricity where it built up in one spot and then it might spark and jump to another spot, but it wasn't continuously flowing. Now, current is defined as positive current flow. We know it's actually electrons, but Ben Franklin and the first people who started studying electricity, they didn't know about electrons. They knew one thing was positive, one thing was negative. They didn't know what was flowing. They assumed it was positives flowing, and that's how they defined current, and it's still how we define current today. So I'm going to draw a little picture down here. This symbol right here is a battery. And the long line represents the positive side, and the short line is the negative side. And then we're going to hook that up to a resistor and then connect it to the other side of the battery. So we're going to label this as our resistor. Now, we know what's really happening is electrons are going to be repelled from this negative side. So electrons are going to flow this way. Okay. Now, if positives were flowing, they would be repelled from the positive side. It would be going the other way. And that's the way we define current. So I is the letter that stands for current, and it goes the opposite way that the electrons are flowing. So in this case, the electrons are flowing counterclockwise around the loop, but we're going to say the current is going clockwise. Now, our equation and units for it. If I want to know how fast somebody's running, I time their distance and do distance divided by time. If I want to know how fast charge is flowing, I do charge divided by time, and that's going to give me the current. Now, our first example, what is the current if 30 coulombs of charge are flowing through a circuit each minute? So I equals Q over T. I was given Q right here, and I'm given T right here, okay, and I'm going to solve for current, which is I. Now, the only trick to this one is the time needs to be in seconds. So I is going to be 30 coulombs divided by 60 seconds, and that's 0.5 coulombs per second. We don't say coulombs per second usually when we're talking about current. The unit for it is amps, so we can say that that's equal to 0.5 amps. So an amp is defined as a coulomb per second. Next example, a current of 3 amps is flowing through a wire. How many electrons pass through the wire each minute? So let's write down the givens. I'm given I is equal to 3 amps. T is 1 minute. And my unknown is number of electrons. I can't solve for that directly, but I can plug into this equation. I equals Q over T. So 3 equals Q over, again, I have to be in seconds, so the time was 1 minute, that's 60 seconds. And then when I cross multiply, I will get Q is 180 coulombs. Now, to get from coulombs to electrons, remember 1 electron has a charge of 1.6 times 10 to the minus 19 coulombs. So I can convert by turning this into a fraction. 1 electron is equal to 1.6 times 10 to the minus 19 coulombs. I put the coulombs on the bottom so these cancel, and that tells me I'm going to divide. So my answer is going to be 1.125 times 10 to the 21st electrons are flowing through that wire each minute. It's encouraging that you get a really big number for that because you should end up with lots and lots of electrons flowing through the wire. And our last example, a current of 4 milliamps is flowing through a wire. How long will it take for 80 coulombs? So again, I'm going to write down my givens. I was given I is 4 milliamps. And we have to know that milli means times 10 to the minus third. And then how long will it take? So T is what I'm looking for. I'm looking for the amount of time. And the charge is 80 coulombs. So I equals Q over T. 4 times 10 to the minus third equals, our Q was 80 divided by T. And then if I cross multiply and divide, I get T is 80 divided by 4 times 10 to the minus third. And that's going to give me a value 20,000 seconds.